Hey guys, Mr. Backwork here. In this video, we're going to look at adding and subtracting polynomials. Now, before we get into the actual adding and subtracting of polynomials, there's a little bit of vocab stuff that we need to cover. And the first vocab word that we're going to talk about is a monomial. And a monomial is an algebraic expression that only has one term. Now, that term could just be a number, or it could just be a variable, or it could be a product of a number and a variable. So I've got some examples on screen for us. So we said that it could just be a number. So 12 is a monomial. Now I also said that it could just be a variable. So this y right here is a monomial. It's only got one term. And then it also could be a product, so multiplication of a number and a variable. So 5x, which really means 5 times x, that is also a monomial all by itself since it only has one term. Now if we're looking at something like 5x, that number that's in front of the variable has a special name to it. That number in front, in this case that 5, is called a coefficient. And that just means the number attached to the variable. Now there are also some things out there that don't count as monomials. So here's an example of one, having 5 plus x. The only way that you're allowed to have a number and a variable mixed together and still have it be a monomial is if there's multiplication between them. You're not allowed to have addition or subtraction and still have that count as a monomial. So 5 plus x, because of that addition, not a monomial. Now here we've got a fraction. When we're looking at a fraction, we're not allowed to have a variable in the denominator of the fraction. That does not count as a monomial. Now, sometimes our variables are going to have exponents on them, but in order for something to be a monomial, we don't want to have negative exponents. So having this negative first exponent on here makes this one not a monomial. And also, when we're talking about exponents on things, we also don't want to have variables as an exponent. So you're only allowed to have number exponents, and like we mentioned before, those numbers have to be positive numbers. So all of these are different examples of things that are not monomials. Now, kind of taking things another step further, we're going to build up from a monomial, and now we're going to talk about a polynomial. So a polynomial is a sum of two or more monomials. And depending on how many monomials you're adding together, that's going to give you a polynomial with different amount of terms. And depending on how many terms your polynomial has, sometimes we give those things special names. So for example, a binomial is a polynomial that has two terms. So for example, x plus 7 has two separate monomials being added together. So it's got two terms there, making it a binomial. Now if we had something with three terms, we would call that a trinomial. So here we've got the example x squared plus 3x minus 4. So this is a polynomial with three separate terms being combined with addition and subtraction. So here's an example of a four-termed polynomial, and there are some special things that I want to point out about polynomials using this example. And the first thing that I want you to notice is, as we're looking at the exponents, when we write out a polynomial, we always want to write it in power descending order, meaning that we're going to go from the highest power and count down to the lowest power. Now the next thing that I want to point out, we talked about putting the polynomial in order going from highest to lowest, and we also talked about coefficients earlier on. Coefficients were numbers in front of the variables. When you have your polynomial written in power descending order, that first coefficient is called the leading coefficient. Now if you look at this polynomial, everything has a variable on it except for that very last term. If you run into a term that doesn't have any variable attached to it, that's called a constant term. And then one other thing, the degree of a polynomial, as we're looking at what we've got for the exponents, the degree of the polynomial is the biggest exponent that we see within the polynomial itself. So as we're looking at this polynomial, we have it written in power descending order, so that front power is going to be the degree for this polynomial. So this is a third degree polynomial. So real quick here, we're going to look at a couple examples of rewriting a polynomial in power descending order, identifying the degree, and also identifying the leading coefficient. So as I look at what I've got for my polynomial, 15 minus x cubed plus 3x. We want to put our polynomial in power descending order, so going from highest power to lowest power. So I'm going to look for the largest exponent. So I see this x cubed. That's got the biggest exponent, so we want that to be first. Now this is technically a minus x cubed or a negative x cubed, so I do need to take the negative with the x cubed. Now as we look at those other pieces, that 15 doesn't have a variable on it, but the 3x does. Now that x itself doesn't have a power on it, which means a first power, so that would be the next lowest power as far as our variables go. It's a plus 3x, so I go plus 3x. And then that 15 is the only thing that we have left. That's our constant term. It's a positive 15, so I'm going to put plus 15 on the end. So we took that polynomial and rearranged it in power descending order. Now the next thing we're supposed to identify is the degree. So the degree is the highest power. So this is going to be a third degree polynomial. And we're also supposed to identify the leading coefficient, which is the number in front of the highest powered variable. So in this case, we've got that negative in front of our x cubed. So that really means that we've got a negative 1 in front of there. So the leading coefficient is negative 1. Now we're going to do the same thing with this one. We're going to put it in power descending order, identify the degree, and identify the leading coefficient. So the biggest power I see is this sixth power. So I'm going to go negative 10x to the sixth. Then the next highest power is this x to the fourth. So plus 14x to the fourth. And then I see this x squared. So plus 12x squared. Looking at the highest power, that's the 6. So this is a sixth degree polynomial. And then as far as the leading coefficient, the number in front of the highest powered x, we've got negative 10. And then for our last one, we've got 3 minus 7x. Again, we're going to rearrange it to be in power descending order. So this negative 7 has an x attached to it, whereas the 3 doesn't. So I'm going to go negative 7x plus 3. So then this one, there's no power on that x, which means an implied power of 1. So this is a first degree polynomial with a leading coefficient of negative 7. Now when we're looking at adding polynomials together, we're only allowed to combine the like terms. And that means the same variable and the same exponent. So here in this first example, we've got 2x cubed minus 5x squared plus x. And we're adding 2x squared plus x cubed minus 1. So the first thing I want to do is identify the things that have the same variables and the same exponents. So if I look in the front of this first polynomial, I've got 2x cubed. So in my second polynomial, I also want to find the things that have x cubed on them. So in the middle, I see this plus x cubed. Now when we're adding, what we're going to do is just add the coefficients. So in front of this first x cubed, I have a 2. But in front of this other x cubed, I have just a 1 in front of there. So if I add those together, well, 2 plus 1 is going to give me 3, but then I keep the x cubed on it. Then I want to look at the next lowest power. So in my first polynomial, I have this negative 5x squared, and for x squareds in my second polynomial, I have 2x squared. I want to add those together. So negative 5 plus 2 is negative 3, but then I keep the x squared on it. Now if I look at my first polynomial, I've got this plus x, which is technically an x to the first power. If I look in my second polynomial, I don't have anything that has just a plain x on it. So this is just going to stay as a plus x. And then if I look, the only thing I have left over is this negative 1 constant term. My first polynomial didn't have a constant, so I don't have anything to combine with this negative 1. So I just leave the negative 1 on the end. So we added up all the like terms, and we ended up with 3x cubed minus 3x squared plus x minus 1. Now, as we look at this next example, we're going to do the exact same thing. Try to identify the like terms and then add them together. So we have 3x squared plus x minus 6, and we're adding x squared plus 4x plus 10. As I look at my polynomials, the first thing I see is this 3x squared. So I want to check for x squareds in my other polynomial. So right here I have an x squared. There's no coefficient on it, so that means 1x squared. If I take 3x squared and add one more x squared, that's going to give me 4x squared. Then I look, I have this plus x, and in my second polynomial, I have a plus 4x. Well, this first x technically has a 1 in front of it, so 1x plus 4 more x's is going to be plus 5x. And then if we check, we do have a couple of constant terms. I have a minus 6 or a negative 6 and a plus 10. If we add those together, negative 6 plus 10 is going to give me plus 4. So we add up the like terms, and we got 4x squared plus 5x plus 4 as our answer. Now, subtraction always seems to get a little trickier for people, so here's what I like to do. In this example, we see that we have one polynomial minus another polynomial. What I'm going to do is I'm going to distribute that negative into the second polynomial, and that's actually going to let me turn this into an addition problem. So we're not going to change the first polynomial at all. That's going to stay as 4n squared plus 5. But I'm going to take this negative that's in between these for the subtraction, and I'm going to distribute that into my second polynomial. So if I take this negative and multiply it by this negative 2, well, a negative times a negative turns into a positive 2, and then n squared. Then if I take this negative and distribute it to that plus 2n, well, a negative times a positive is going to turn that into a negative 2n. And then if I take the negative and distribute it to the negative 4, again, double negative turns that into a plus 4. Now, when you do that distributing, that actually takes that minus that was between them and it turns it into an addition problem. So now we're doing exactly what we were doing on the previous examples and just trying to match up those like terms and add them together. So in my first polynomial, I see that we have 4n squared. And in my second polynomial, I see 2n squared. So 4n squared plus 2n squared is going to give me 6n squared. Now, my first polynomial doesn't have any n's with a first power on it, but my second polynomial does. It has a minus 2n there. There's nothing to combine with it, so it's going to stay as a minus 2n. And then if we look, we do have a couple of constants. We've got this plus 5 from the first polynomial and a plus 4 from the second polynomial. If we add those together, that's going to give me plus 9. So we get 6n squared minus 2n plus 9 as our final answer. Now in this next one, we've got 4x squared minus 3x plus 5, and we're going to subtract 3x squared minus x minus 8. So just like we did in the first one, we're going to leave the first polynomial alone. We're not going to make any changes there at all. And we're going to take that negative, or that subtraction that's happening between them, and we're going to distribute that into the second polynomial. So taking this negative times the positive 3x turns that into a negative 3x squared. Taking the negative times the negative x, double negative turns that into a plus x. And the negative times the negative 8, again, double negative turns that into a positive, so that becomes a plus 8. Now, when we distribute that negative in, that turns into addition between these. Now, I'm looking for those like terms. I have 4x squared in my first polynomial, and in my second polynomial, I have minus 3x squared. So if we add those together, 4 plus negative 3 is going to give me 1x squared, but I don't really need to keep the 1 on that, so I'm just going to write it as x squared. Then if I look, here I've got a minus 3x and a plus 1x. So negative 3 plus 1 is negative 2x. And then lastly, we've got a plus 5 and a plus 8. If we add those together, we get plus 13. So we get x squared minus 2x plus 13 as our final answer on this one. Now, one more example that we're going to take a look at. We've got this triangle, and it says that we want to write out a polynomial that's going to represent the perimeter of the triangle. And we have to remember that perimeter means the distance around the outside of a shape. So what we want to do is all of these expressions represent the specific length of a side of this triangle. To find the perimeter, we want to add all those things together. So we start with one of the sides. I'm going to start with the x plus 7. I want to add on one of the other sides, so let's go 3x plus 8. and then I want to add on that last side, so 9x minus 4. So we're technically adding these three separate expressions together, trying to come up with a new polynomial. We're going to look for like terms. In the first polynomial, I see this plain x, so it's 1x. In my second polynomial, I've got 3x, and my last one, I've got 9x. Those are all like terms, so I want to add all of those together. So 1x plus 3x is 4x, plus 9 more x's is 13x. And then if we look at all of the constants, we've got a plus 7, a plus 8, and a minus 4. We're going to combine those as well. So 7 plus 8 is 15, minus 4 is 11, so plus 11 on the back end. So this polynomial right here, 13x plus 11, would represent the perimeter of this triangle. That's going to be it for this video. Thanks for watching.